All right, guys, so section 8.3 is graphing quadratics in standard form. So before this, we learned how to do quadratics in vertex form. Well, with this form, there is no vertex at this. So for standard form, we don't have a vertex yet. Standard form is this equation right here, should look very similar to some of the things we were doing in chapter 7. In standard form, in order to graph quadratics, we will determine the value of the x-coordinate in the vertex, which will also be the axis of symmetry, which we learned previously in chapter 8, by using this little equation, x equals the opposite of b over 2a. So you're going to want to memorize this guy here and this equation up here at the top. So essentially what's happening, guys, is when we had vertex form, we knew we could find the opposite of h and then k, and we would have our vertex. We don't have that now. So we're going to have to use this formula that x is equal to the opposite of b over 2a. We then will substitute the x coordinate into the original equation and solve for y. Okay, we'll plot the vertex and use the pattern to graph. Note the y-intercept usually occurs or will occur when x is 0. So usually we're going to look at this and your c value up here is going to be your y-intercept. So watch what happens. Looking at number 1. It says graph x squared plus 5. Here I know my a value is 1, which means this is going to be opening up. All right, since it's opening up, I know my vertex is going to be a minimum. In my axis of symmetry, we're going to have to figure that out by finding x equals the opposite of b over 2a. When I look at my equation, here is my a value, here is my c value. I do not have a b value for this problem. So when I write this down, I'll have x equals the opposite of b, which is 0, over 2 times a, 2. Well, anything divided by 0 is 0. So my x and my vertex is 0. My axis of symmetry will also be 0. Well, if I plug 0 in for x up here in this equation, all right, I'll get y equals 5. So that means my ordered pair for my vertex is at 0, 5. My domain, we know, is always negative infinity to infinity. My range we'll work on here in a minute. Let's go ahead and graph this. So you're going to remember my vertex is at 0, 5. My a value is 1, so before break we talked about how we could do over 1, up 1, over 1, up 3, and over 1, up 5. That works when a is 1. So here is my parabola. All right, now they want to know the range from low to high. Remember, we use brackets when it includes that number. So the lowest my parabola is at 5. The highest is infinity. Then we use parentheses. My y-intercept, we decided earlier, was 5. That can also be written as 0, 5. And we can see that from my graph at this point right here. Okay, let's take a look at number 2. We don't know my vertex, so I need to find that. I find my vertex by doing the opposite of b over 2a. So let's go ahead and talk about this graph. Is it opening up or down? Well, I see my a value is 1, so I know it's going to open up, which means the lowest point on my parabola is the minimum. All right, because it's going up. My axis of symmetry I need to find next. To do that, I need to find my x value. X equals the opposite of b over 2a. My b value is 6, so negative 6 over 2a would be 2 times 3. When I simplify that, I get negative 6 over 6, which is negative 1. Negative 1, all right? So to do this one, because of order of operations, a lot of times I plug this into my calculator to help me out. I know my x value in this equation is negative 1. So to find my y for my vertex, I'm plugging negative 1 into all of my x's up above. When I do that, I get negative 4 for my y-intercept, which means negative 1, negative 4 would be my vertex. So negative 1, negative 4. My graph will go over 1 instead of up 3. It's going to go up 3 times 3 is 9. So over 1 up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And over 1 up 9. And then over 1 up, instead of, it's 1, 3, and 5. Over 1 up 1. Ooh, some of you guys are going to notice my mistake in there. Instead of up 9 that first time, it's over 1 up 3 because we multiply by 1. And then over 1 up 9. So those two dots should not be on there, sorry. There we go. Okay, domain, negative infinity to infinity in parentheses. Range, the lowest it can hit is going to be -4 with a bracket to infinity. My y-intercept, where it hits my y-axis, is going to be right here at -1. And we can see that up here for my c value. So I'm going to write that as 0, -1. Okay, so this is standard form, a little different than vertex form, but we're going to continue working on it. So looking at this problem, 3. A is negative, so we know it's going to go down. Okay, is that a minimum or maximum? Well, the vertex then is going to be the maximum, right, because my graph is going down. Axis of symmetry, we need to find. So the opposite of B is -8 over 2A would be -4. So I'll get x equals 2. I'm going to plug that back into my equation. So in our calculators, we will do -2 times, let's see, 2 squared plus 8 times 2 minus 3. That's going to give me 2, 5 as my ordered pair for my vertex. So I'll go in and find 2, 5 as my vertex. Domain, always negative infinity to infinity. Range, we need to find. I know this is pointing down. So instead of over 1 up 1, over 1 up 3, over 1 up 5, remember we're going to multiply that by -2 because my a value is -2. So I'll get -2, -6, and -10. So over 1, down 2. Over 1, down 6. 3, 4, 5, 6, and 6. Okay, and then over 1, down 10, that's going to be off my graph. Oh man, sorry. I see my y-intercept right there where it's crossing my y-intercept, or my y-axis, is at -1, 2, 3. So 0, -3 is where it's hitting the y-axis. And I see that the range from low to high will be negative infinity. The highest it's going to be able to be is 5. All right. I want you guys to go ahead and try number 4. And then we're going to go ahead and do number 5 in class. So this is just a brief overview for those of you that could not make class today to do 8-3. Make sure that you fill those out and come see me in class tomorrow, please.